Hello students and seekers of truth. In this video, I am going to explain to you how to convert binary numbers to decimal numbers and vice versa. And then the idea is that you can take the process that I've described here, understand what the algorithm and how it works, and write a computer program to do the same thing, faster, more efficient than doing by hand. So let's go from binary to decimals first, because that is certainly the easier of the two methods. So let's start with a binary number. Let's just say it's 1 0 1 1 0 1. Okay, and so remember here that this is really understanding place values, right? So this is 2 to the 0th power. This is 2 to the first power. This is 2 to the second power, 2 to the third, and so on. So it's not unlike a decimal, a base 10 number, but except instead of powers of 10, we just have powers of 2 along the way. So when we go to add up these numbers, we simply take the values that are 1. So let's just go in order. This would be 1 times 2 to the 0 plus 0 times 2 to the first plus 1 times 2 to the second plus 1, that's right here. This is 2 to the third plus 0 times 2 to the fourth plus 1 times 2 to the fifth. Okay, and whatever the total is here, that's our number in decimal. So I basically ignore these ones right here. They're multiplying by 0. And so what do I have here? 2 to the 0 is 1. 2 to the second is 4. 2 to the third is 8. And 2 to the fifth is 32. So for a grand total, I have 45. So this binary number here, 101101, that is the same thing as the number 45 in decimals. So to convert something from binary to decimals, it's not too complicated. You start at the rightmost digit or the least significant digit, work your way to the left, and you can actually go in the other direction too if you want, but it's a little bit trickier writing computer code because you have to know how long the decimals or the binary string is. So not too complicated going from binary to decimal. Now going in the other direction is going to require a little bit more thinking. All right, so now let's look at an example of going from decimal to binary. And there's a couple different methods to this. I'm going to show you the method that most people start with because it's really doing the reverse of binary to decimal. So you have a number here, let's say you have 159, and you just list out the powers of 2, but not bigger than the number that you're working with. So I've listed out here 1, 2, 4, 8, 16, 32, 64, so on, all the way to 128. So 128 is the biggest power of 2 that is less than 159. So now we're going to rewrite 159 as 128 and then subtract 128 from 159. So this would be 31. Okay. So I have a power of 2 here, and then I have this number 31, and I ask what's the biggest power of 2 that is less than 31. So in this case, that's 16. So now I'm going to rewrite this problem as 128 plus 16 plus 15. Okay. So I have a perfect power of 2 up here, power of 2 here, and then I repeat the process. What's the biggest power of 2 that is less than 15? Well, that's 8. So I'm going to rewrite this as 128 plus 16, and then instead of 15, that will become 8 plus 7. And then we're going to do the same thing with the power with the 7. 7 here is going to be 4 plus 3. I'm speeding things up just a little bit. And 3 is really just 2 plus 1. Okay. So now when I fill all these stuffs down, I have 159 is really equal to 128 plus 16 plus 8 plus 2 plus 1. And then I take all of these and convert it into powers of 2. So remember, 2 to the 0th power, that's this number. This is 2 to the 0. This is 2 to the 1st, so I have a 1 here. 2 to the 2nd is not on here. 8 here, that's 2 to the 3rd. 2 to the 4th is 16, that's on here. So that becomes a 1. Right, so this is 2 to the 4th. 2 to the 5th, I'm going to move over 2 to the 5th, that's not on there. 2 to the 6th. So 2 to the 5th, 2 to the 6th, that's not on there. And then this is 2 to the 7th, that's 128. So converting 159 into binary, it's 10011011. And if we were to take this binary number and convert it back to decimal using the previous steps from above, we would come back to 159. Okay. Now, this process is okay. It's not great. It's okay. It's a very simple process to follow. The only downside to this process is that you just have to have a lot of powers of 2 memorized. And then now, even if you were coding this, you don't have to have it memorized, but you end up with a lot of different loops that you have to run in order to produce the binary number that you want. So I'm going to show you another algorithm here that's much more elegant than what I have. All right, so let's look at this example with a fairly large number, 19,760,127. So this is a decimal number, a base 10 number, and we wanted to convert it to binary. And we don't know exactly how it's going to look yet, but we do know there's going to be some place values. Right? So I'm just going to write out a few here. I'm going to list this out. Okay. And my first question is, in the far right here, is this going to be a 0 or a 1? Okay, and if you can kind of answer that and reason through it, the rest of the problem will fall into place fairly easily. And so how would we determine if this is 2 to the 0th power, right, which is equal to 1? Right, so is this going to be a 0 or a 1? Well, if you study this number, note that this number is odd, right? And if we have a power of 2, all the powers of 2 are even numbers. So for this number to be odd, this number back here must be a 1. Okay, so we know for sure. So the first question is, we asked, is it odd? Okay. If the number is odd, then we must have a 1 right here in its place. Okay, and so now we're on to the second place value. Now, how do we know whether this number is going to be odd or is going to be even? Well, the nice trick to doing this is that we can then, since in this case we know that the number is odd, we can subtract 1 from it. So we're going to subtract 1. And then we're going to divide it by 2. Okay. So 19,760,126 divided by 2. That gives me a new number, 9,880,063. Okay. And so now that I look at this number, now notice here I've divided the number by 2, so it's like it's got fewer places. It's like I draw an imaginary line here. I don't have to worry that anymore. I just look at this new number and I have to determine whether this place value here is going to be a 1 or a 2. Well, to know that, I just have to look at this number and ask myself the same question again. Is it odd? If it is odd, then I'm going to get a 1 back here. If it's not odd, then I'll put a 0 back here. Now, in this case, this is odd, so I'll put a 1 there. And then I'll subtract 1 from this number, 9880063. And, oh, this is 62, excuse me. I'm subtracting 1. Okay. And then I'll divide by 2. Okay. So 988. So now I get a smaller number, 4940031. So 4,940,031. And so now I'm concerned with this place, with the next place value over this one right here. The question is, well, the number that I'm looking at, is it odd? Well, yes, since it is odd, we'll put another 1 in this place. And then it's like, well, I'm gonna move my little divider line here, right? I already got to figure that out. Now I'm gonna repeat the process. And when I divide by, I'm gonna subtract 1, and then I'll divide by 2 again. And this time we're gonna get an even smaller number. 2,470,015. Okay, and we'll repeat the process. This turns out to be odd as well. Okay. So we're going to get a string of ones here, and then you can see, I think you can see the pattern by now. We're just going to repeat the pattern. I'll just move this little divider to here. We will subtract 1 and then divide by 2. So I get 1,235,007, and we'll keep on dividing by 2. So we get, so this number here again is odd. We'll repeat the process. Minus 1 divided by 2. I'll move it over here. We get 617,503. That turns out to be odd, so we'll put a 1 there. Minus 1 divided by 2. We get 308,751. That's also odd. Put another 1 here. 15,435. Another odd number. So we're putting a 1 in those place values. 7, subtract 1 divided by 2, 77187. That's again another odd number. Okay. Repeat the process. 38,593. And then now when we subtract 1 and divide by 2, we get something a little bit different. We get 19296. And this number here is not odd. It's an even number. Well, since it's an even number, we put a 0 in this slot right here, because we know that if we, let me move my barrier here that we're looking at now. So we're looking at this barrier right here, and we're working with a smaller number now. And this number here, this number that we're working with, it's not an odd number, so there's not a 1 here that we're adding onto it. It's a 0 placeholder. Okay? So we put a 0 in here, and since we have an even number, we don't subtract 1. We just take this and we divide by 2. And I happen to get 9648. Again, it's an even number, so we'll put a 0 in this place. We don't subtract 1, we just keep dividing. Repeat the process. We get 4824. 4,824. So that's another 0. Divided by 2. Now we get a string. Now we're getting like a string of even numbers. So 2412. So that's a 0. Divide by 2. We get 1206. So I need another place value here. divided by 2 again. This time we get 603. Okay, and we're working all the way down here. So that's odd, so we put a 1. Then subtract 1 divided by 2. You get 301. That's an odd number. Subtract 1 divided by 2. That gives you 150. 150 is an even number, so that gives you a 0. Just divide by 2, you get 75. That's clearly odd. Okay. Subtract 1 divided by 2, you get 37. That's odd. Subtract 1 divided by 2, you get 18. So that's even. And then 9, that's odd. Subtract 1 divided by 2, you get 4. That's even. Then 2, you're going to get an even number. And then 1, and then you're going to get an odd right here. And then after that, everything is going to be zeros, right, all the way down if you keep on dividing by 2, or you get some negative numbers. But at this point, you can stop once you start getting negative numbers. So you get a bunch of zeros over here, kind of useless zeros, so I'll just erase that. And this, even though I know it seems a little bit more tedious, and it was tedious in a way because I chose a really big number here, 19,760,127. But the algorithm is actually, when you go to code this, it's much simpler to code. You ask the same questions repeatedly. Is it odd? If it is, put a 1 here. If it's not, put a 0 here. And then subtract 1 and divide by 2. And it's just a little hint when you go to write this code, instead of subtracting 1 and dividing by 2, you could use integer division to accomplish the same thing in a much shorter step. Okay, so there you have it, a couple of different methods here. We have one method for converting binary to decimal. That's pretty standard. A method for converting decimal to binary just by accumulating large powers of 2. And then we have this third method where we essentially keep shrinking the number that we're working with, and along the way just study the parity, whether it's odd or it's even, along the way in order to build up our string of binary numbers. Thank you for watching, and have a wonderful day.